A team of researchers sat down with new James Webb Space Telescope data and did something almost deliberately unglamorous. They picked a narrow slice of the infrared spectrum that most previous studies of Pluto and Titan had barely bothered to examine, a range of wavelengths nobody considered, a priority. And they started checking it carefully, band by band, against everything humanity has ever cataloged about how known molecules absorb light. It was the kind of painstaking, unglamorous work that rarely makes headlines. Then they found something that made this particular search anything but routine, a gap in the spectrum, a specific wavelength of light quietly missing from the surface of Pluto, and the exact same wavelength missing from the surface of Titan, Saturn's giant moon, 100 million miles away. They checked their reference library. They checked it again. Nothing matched. This is the real story of what James Webb actually found hiding on two of the most extensively studied worlds in our solar system, why the scientists behind this discovery say it doesn't correspond to any documented molecule A, nowhere in the published scientific record, and why the answer to this specific mystery might not come from a telescope at all. I'm your host, and this is your channel. If you want the real science behind the biggest discoveries in space, subscribe now, because we're just getting started. Let's start with the tool that makes a discovery like this possible in the first place, because understanding exactly how astronomers identify chemicals on distant worlds is what makes this specific gap so hard to explain away. Every molecule in the universe absorbs light at very particular, predictable wavelengths, a direct consequence of quantum mechanics governing how electrons within that molecule can absorb and release energy, shine a full spectrum of light through or off any material, and whatever molecules are present will each carve out their own tiny, precise gap, a dark absorption line at exactly the wavelength that specific molecule is built to absorb. This isn't a rough approximation. It's one of the most exact identification tools in all of science, refined over more than a century of laboratory work, cataloging precisely which wavelength corresponds to which known chemical compound. Astronomers use it to identify oxygen in the atmosphere of a planet light years away, methane in the clouds of a gas giant, water vapor drifting through the debris disk of a forming star system. If you know the wavelength, you generally know the molecule. That reliability is exactly why this new finding has genuinely puzzled the researchers involved. In a study first, posted to the preprint server Arxiv on June 11, 2026, and picked up by multiple science outlets in the first week of July, a research team examined James Webb data from two dramatically different worlds: Pluto, the small, frozen dwarf planet sitting at the edge of our solar system, and Titan, Saturn's enormous moon, larger even than the planet Mercury. Rather than focusing on the wavelengths astronomers typically prioritize, the team deliberately combed through a range of shorter wavelengths that had received comparatively little attention in prior observations of either world. And in both datasets, independently, they found the same specific, well-defined gap in the spectrum, centered at almost exactly 511 micrometers. Here's where the actual detective work began. The team went back through the accumulated scientific literature, checking their finding against every previously documented molecular absorption band they could locate, the same reference process that normally resolves this kind of question within minutes. According to the researchers' own words in their published paper, they did not find any band referenced in these publications that corresponds to the location of the observed absorption in Titan and Pluto. That's a genuinely unusual outcome. It means this specific wavelength, precisely measured, cleanly detected, consistently present on two separate worlds, simply isn't associated with any chemical compound currently documented anywhere in the published astronomical or laboratory record. What makes the mystery deepen, rather than resolve once you start comparing Pluto and Titan directly, is exactly how little these two worlds actually have in common. Titan possesses a thick, hazy atmosphere with surface pressure roughly 50 times greater than Earth's own, dense enough that it has historically made detailed study of the moon's actual surface genuinely difficult, since researchers first have to see through all of that atmospheric material before they can get a clean read on what's happening at ground level. It's also the only world in our solar system besides Earth known to have stable liquid on its surface, vast rivers, lakes, and seas, though on Titan that liquid is methane and ethane rather than water. Pluto, meanwhile, is a completely frozen dwarf planet roughly half of Titan's size, sitting on average about 4 times farther from the Sun than Saturn itself, with an atmosphere so thin it's barely comparable to Titan's thick shroud at all. Different sizes, different distances, different atmospheric density, different physical environments in nearly every measurable way. And yet, according to this new analysis, both worlds carry the exact same unidentified chemical signature. The research team was able to nail down one crucial detail with genuine confidence. The molecule responsible for this absorption appears to be sitting directly on the surface of both worlds, rather than floating somewhere in their atmospheres. That distinction rules out a simple coincidence involving two unrelated atmospheric gases that happen to absorb light at a similar wavelength purely by chance. Whatever this substance actually is, it's physically present, on the ground, on two bodies whose only meaningful chemical overlap is that both have surface and atmospheric chemistry built around methane and nitrogen. Even though the specific temperatures, pressures, and physical conditions surrounding those shared basic ingredients are dramatically different between the two worlds. The finer details the team extracted only add more texture to the puzzle, exactly the kind of clues a genuine scientific detective story depends on. Pluto's version of the absorption line measured roughly 3 times thicker than T. Itan's, suggesting the unidentified molecule, sits in significantly greater abundance on the dwarf planet's frozen surface. On Titan specifically, the substance isn't spread evenly across the moon at all. It shows up more strongly on Titan's trailing hemisphere, the side of the moon facing away from the direction of its orbital motion around Saturn, than on its leading hemisphere, which faces directly into that path. That kind of lopsided, hemisphere-specific distribution is exactly the sort of pattern planetary scientists rely on to work backward toward a physical explanation, since processes like exposure to Saturn's powerful magnetosphere, differing rates of solar radiation, or specific photochemical reactions often affect the leading and trailing hemisphere in measurably different ways, and each candidate explanation for the mystery molecule would be expected to leave behind its own distinct fingerprint of distribution. Faced with a genuine unknown, the research team didn't simply file the finding away as unexplained and move on. They proposed several specific, scientifically grounded candidate molecules based on what kinds of compounds could plausibly form under Titan and Pluto's particular surface conditions, and might reasonably produce an A-B sorption feature in roughly the right part of the spectrum. Their leading hypotheses include benzene, a ring-shaped hydrocarbon molecule, possibly combined with some other, still unidentified compound, or alternatively, specific forms of acetylene ice or keton ice, both entirely plausible given the kind of methane and nitrogen-driven photochemistry already known to occur on worlds like these. It's genuinely important to be precise here, exactly as careful as the researchers themselves have been in their own published language. These remain scientifically informed candidate hypotheses, not confirmed identifications. The paper is explicit that considerably more work is required before researchers can confirm whether any of these specific candidates actually accounts for the observed absorption feature. And as of this recording, the study itself has been posted to Argirum, but has not yet completed the formal peer review process that would give it the additional scrutiny and validation the broader scientific community typically requires before treating a finding as fully established. So how does a mystery like this actually get solved when checking against the full existing catalog of known molecular signatures hasn't turned up an answer? The most promising path forward isn't another telescope observation at all. It's a spacecraft that hasn't left Earth yet. NASA's Dragonfly mission, a nuclear-powered rotorcraft lander currently scheduled to launch no earlier than 2028, and expected to actually descend through Titan's thick atmosphere and land on its surface in 2034, carries its own onboard spectrograph, an instrument built specifically to sample and analyze Titan's surface chemistry directly, up close, rather than reading it indirectly from sunlight reflected across hundreds of millions of miles of empty space. The researchers behind this new finding have explicitly pointed to Dragonfly as the most realistic route toward finally identifying this mystery molecule on Titan with genuine confidence, a work that would, in turn, help settle whether the same unidentified substance really does exist on Pluto's surface as well, a question reflected light alone hasn't yet been able to definitively answer. It's worth taking a moment to appreciate exactly what this story represents, and being equally honest about what it doesn't, because that honesty is what separates a genuinely compelling scientific mystery from a manufactured one built purely to generate clicks. This isn't evidence of anything artificial, and it isn't evidence of anything dangerous on either world. What makes it genuinely remarkable is something quieter and, in its own way, more satisfying. Real, direct proof that even two of the most thoroughly studied bodies in our entire solar system, a dwarf planet NASA's New Horizons spacecraft flew directly past in 2015, and a moon whose surface the European Space Agency's Huygens probe actually landed on back in 2005, still contain genuine, unresolved chemical mysteries, sitting quietly in a slice of the light spectrum that nobody had carefully checked until researchers finally decided to look there. Every previous close-up study of Pluto and Titan worked with the specific technology and observational priorities available at the time. It took a new generation of infrared instrumentation, paired with researchers deliberately choosing to examine an underexplored corner of the spectrum instead of following the well-trodden path, to finally notice something sitting there that nobody had a name for. So here is where this genuinely leaves things honestly grounded entirely in what the researchers themselves have published and stated on the record. A precisely measured, clearly defined absorption line, centered at 511 micrometers, has been detected on the actual surfaces of both Pluto and Titan, two worlds that share almost nothing else in common physically, and it doesn't correspond to any molecular signature currently documented anywhere in the published scientific literature. The research team has proposed genuine, carefully reasoned candidate explanations, benzene mixtures, acetylene ice, ketene ice, without yet being able to confirm which, if any, of these is actually correct. And a full, confident resolution of this mystery will most likely have to wait until NASA's Dragonfly mission physically arrives at Titan in 2034 and can sample the moon's surface directly, rather than reading its chemistry secondhand through reflected sunlight from 100 million miles away. That is not manufactured drama built around an exaggerated headline. That is the honest, current, still genuinely unresolved state of a real scientific puzzle, uncovered by patient researchers who simply decided to check a part of the spectrum nobody else had bothered to examine closely. If this kind of story is what you come here for, one grounded in exactly what researchers actually found and are honestly still working to explain, hit subscribe and turn on notifications, because there's clearly more genuine mystery left, even in the corners of our solar system we thought we already understood. Drop a comment telling me which candidate molecule you think turns out to be the right answer, and share this with someone who still thinks every world close to home has already given up all its secrets.